All right, so today we are going to recap how to graph absolute value. What is the shape that absolute value graphs make? They all end up making a V shape, and there was a general formula for them. Do you remember what went inside the absolute value? It was x
minus h.
Ooh, look at you. And then plus
Nope.
k. Right. So this is our general formula for absolute values. A is going to represent what? Do you remember?
Slope.
Yeah, that's the slope of your right-hand branch. Right-hand branch. And then, so that's A. And then what was the slope of the left-hand branch? Negative A. Slope of left. And then h comma k was what? Yes, that is the coordinate of your vertex. So, very quickly, if I wanted to graph something like y equals x plus 3 minus 1. Okay? There's no number in front here, so what number is really there? A 1. So that just means I'm going to have a normal V shape. It's going to have its coordinate at negative 3 comma 1. Remember, because look at how the formula is written. It's always a minus h. So that means that you need to take the opposite of whatever you see there. K will always be what it is. So my vertex is going to be located at negative 3 comma negative 1. And then because my slope is a 1, I'm just going to go up 1 over 1, up 1 over 1 for the right-hand side, and then the opposite on the left. Okay? So, very quickly, if I wanted to graph this, here's a random coordinate plane. Okay, I'd have a vertex at negative 3, negative 1, and then for the right-hand branch, up 1 over 1. And on the left-hand side, I go up 1, back 1, which is a slope of negative 1, right? But to make my V shape, like you're not going to do it down here, we would go that way. All right, and there is the graph of this. Then we did make it a little bit harder yesterday by doing things like, how about y is less than negative absolute value x plus 2. So I had something like that. So now, where will my vertex be? Right. I don't have a number in there in the absolute value, so my h is just a 0. K is on the outside, and that's still a positive 2. What's up with this, though? What does that do? Right, it's going to flip the V upside down. So on the right-hand branch, my slope will be negative 1 on that side, and then I'll have positive 1 on the other side. So it just looks like an upside-down V. So if I wanted to graph this one, so I'm going to start at 0, 2, and then my slope is a negative 1, so I go down 1 to the right 1 on the right-hand side. Okay, and then the opposite on the left, so down 1, back 1, down 1, back 1, down 1, back 1. And then the other thing that changes is that this one's now an inequality. So I don't just willy-nilly connect the dots, I have to stop and think about it. Because this is less than, and it does not have the or equal to, I'm going to connect these with what? A dotted line, right? Which it's already pretty dotted, but anyway. Dotted line, and then that's not dotted at all. Then I have to decide about shading, right? So I put my pencil on the vertex, and then I go back to the original, and it says y is less than. Where are the y's less than, above or below? Below, so in this case, it'll be everything inside this V shape. You can always double check with points. Remember that everything you shade over, you're calling a solution to your original inequality. Anything that is not shaded over is not a solution. I used a dotted line because I do not want to include the points that are actually on the line, just everything up until the line. If the line was solid, I would include points on the line. Okay? And that's pretty much as far as we got yesterday. So, we'll try the harder ones now.